Here, the question is that explain the VI characteristics of Zener diode, or why Zener diode is used in a regulated circuit. Why Zener diode is used in a regulated circuit. Here the VI characteristic is shown here. It shows the VI characteristics of the Zener diode. This is a forward bias region, and here that is the third quadrant that shows the reverse bias region. In forward bias region, the Zener diode, it is like an ordinary crystal diode. Its characteristics, that is the graph of voltage versus current, is similar as the crystal diode in forward bias condition. Here in that condition, in forward bias condition, the VI characteristic of Zener diode is similar. It is like to the ordinary crystal diode, except that the difference is that the Zener diode is properly doped. The doping procedure for the Zener diode is a properly doped Zener diode, so that what's happened, the Zener diode has sharp breakdown voltage. Here in reverse bias condition, in that third quadrant I shown in the graph, the Zener diode shows sharp breakdown voltage. So whenever Zener diode is used in a regulated circuit, it is always connected in reverse bias. That means Zener diode is always connected in reverse bias condition. That point should be noted. When it is in forward bias, its characteristics is just like that of ordinary crystal diode. That means in forward bias, that Zener diode is act as a ordinary crystal diode. Here now, what is the difference of the Zener diode? See, in that reverse bias condition, here at Zener voltage V shade, that is on x-axis there is a voltage, on y-axis there is a current. In reverse bias condition, when it is connected in reverse bias condition, what's happened? In reverse bias condition, I have shown here, at reverse breakdown voltage, that means at V shade, this at this point, that is called reverse breakdown voltage. The current through the Zener is increased sharply, but voltage across it remains constant. That is the V voltage across Zener diode remains constant, but current through the Zener increase sharply. Due to that property, that Zener diode is used in the regulated circuits. So the VI characteristics of Zener diode is shown here. It is a graphical representation of voltage and current. I shown in a VI characteristics in forward bias condition in the first quadrant. The Zener diode is act as an ordinary crystal diode, but in reverse bias condition. At reverse breakdown voltage V shade, the current through the chiller increase sharply, but voltage across it remains constant due to that property that chiller diode is used in a regulator circuits. So that is the application of the chiller diode. Why chiller diode is used in a regulator circuit? That is the reason it is noted that whenever it is used in a regulator circuit, that chiller diode is always connected in reverse bias condition. So that chiller diode is act as a voltage regulator whenever it is connected in reverse bias conditions. Now the next topic, what do you mean by voltage regulator circuit? The regulator is a part of the DC power supply. That is the last part of the DC power supply. The first part of the DC power supply is a rectifier circuit. It provides pulsating DC output. The second part is a filter circuit that provides pure form of DC. But that pure form of DC is not regulated. In many applications in DC power supply, that the output voltage should remain constant regardless of the variation in line voltage and load current. So for that purpose, regulator circuit is used. That regulator circuit having input, that is the unregulated DC, that is the output of the filter circuit. It is the input to the regulator circuit, and regulator circuit provide regulated constant DC output. So definition of that regulator circuit, that the circuit which provide constant regulated DC output voltage irrespective of change in line voltage and change in load current. What's happened sometime in a DC power supply, the line voltage is a 230 volt AC. That should be varied, that should be changed, and due to variation in line voltage, the DC output voltage is also changed, it also varies. Again, the second factor is the load current. The load current, that means the output current, that means whenever that load current is changed, it is varied, the DC output voltage is also varied. So regulator circuit, whenever we are using regulator circuit in DC power supply, the regulator circuit provide constant regulated DC output voltage irrespective of change in line voltage and load current. So there are terms related with the DC power supply. First term is a load regulation. It is defined as a percentage change in regulated output voltage for change in minimum load current to the maximum load current. Here it shows that if V1 is the output voltage for the minimum load current, that is a no load condition. That is called the no load condition. And V2 is the output voltage for the maximum load current, that is called as the full load condition. Here that is called as the full load condition. So load regulation can be calculated as V1 minus V2 upon V2 multiplied by 100. So that is the formula for the load regulations. Second factor is a line regulation. It is defined as a percentage change in regulated output voltage for change in input voltage. Whenever the line voltage is changed from minimum value to the maximum value, at that time the line regulation can be calculated as the formula. Here the formula is given as a line regulation is equal to V maximum minus V minimum divided by the V nominal multiplied by 100. V maximum is the output when input voltage is maximum. V minimum is the output DC voltage when input voltage is minimum, and V nominal is the output DC voltage when input voltage is 230 volt. And the third definition, that is a ripple rejection ratio. It is the ratio of peak to peak input voltage to the peak to peak output voltage. So that is the three terms which are related with the